Alright guys, so we are going to be talking about systems of equations, and a system of equations is when you have two or more equations, and a solution to your system is when the value or the point where both the equations are true, or where both of them are equal. And so when you're graphing, which is what we're going to do today, we want to find where they intersect. So when you graph, you've got to have it in slope-intercept form, which is this y equals mx plus b. Your m is your slope, your b is your y-intercept. So for these two equations, y equals x plus 3 and y equals negative x plus 1, we have a lovely, these are already both in slope-intercept form, so we can just graph them. So the slope of our first line is 1 and the y-intercept is positive 3. So we start up here on the 3, and then we begin with our b and we move with our m. So we go up 1, right 1, up 1, right 1. I'm also going to go down 1, left 1, down 1, left 1, down 1. I'm just going to kind of make my little lines there. Do y'all feel good about that as we're doing it? Cool? So that would be how I would graph my first line. All right? And then our second line here, we have y equals negative x minus 1. So guys, what's the slope of my second line right here? What's the m of the second line, y'all? Negative 1. And what is the b of my second line? Oh, it's also negative 1. So we are going to start at negative 1. And then we are going to, because that's where our y-intercept is, and then we are going to move with negative 1. Sometimes I like to write it as a fraction, because then that's more like the rise over the run. So we're going to go down 1, right 1, down 1, right 1, down 1, right 1. We can also go up 1, left 1, up 1, left 1. Okay? And when we do that, I'm going to graph my lovely equations here, and we have a system. Does that make sense, y'all? And so what is the solution to this systems of equations, y'all? Do we have it right here? There it is. That is our solution, because that is where they intersect. Does that make sense? So what is the solution? It is negative 2, positive 1. So the solution is a point. Does that make sense? So in this case, we have one solution because it's the point on the graph. Do y'all feel good about that? Yes, no, maybe so? Okay. So guys, now here's the cool thing is, yes, we can do this by hand. On your homework today, you're going to have to do it by hand. But guys, we can also do this in our lovely calculator, where if we graphed x plus 3, oops, I'm going to graph it in the top one there, x plus 3, and we did negative x minus 1, we would actually be able to see the solution. Do y'all feel good about that? About how we can see that there? Now, how could I calculate the intersection of that solution? Any ideas? Second trace. You find your intersection there. Then you hit enter, enter. And then your guess, you kind of can scroll to your guess, or you can just do enter, enter, enter. And it gives you the solution. And guys, you see on your calculator right there, oh gosh, this is like very glary. It tells you that the intersection is negative 2, 1. So your whole solution is that negative 2, 1. Do you guys feel good about that? About being able to find that intersection there? All right? You can also find it on your table, because at negative 2, both of your y values are the same. It's negative 2, 1 and negative 2, 1. So both the y values are the same as well. All right? Do you guys feel good about that? About being able to find that on the calculator or just doing it by hand? Okay? So we're going to do a few more by hand just to get some good little practice here. All right? So let's look at number 2. So we are going to do 3x minus y equals 2 and negative 6x plus 2y equals 6. Now guys, Can I graph these equations right here? Why not? They're not in slope-intercept form. We've got to get them in slope-intercept form. So we have to get it into y equals. So guys, the first thing we can do is we can solve for y. So I'm going to bring this guy over here. I'm going to bring over this top equation. And we have 3x minus y equals 2. And so I'm going to subtract 3x from both sides. So I have negative y equals negative 3x plus 2. Have I solved for y completely? I need to divide by negative 1. And when I do that, I have y equals positive 3x minus 2. Do you guys feel good about that? That is one of my equations. All right? Now, if we want to find the other equation, so that is one of mine in slope-intercept form. Is this guy in slope-intercept form? No, it's not. It's really annoying. So we are going to add 6x to both sides, which gives us 2y is equal to 6x plus 6. Divide everything by 2. So you have y is equal to 3x plus, 3. Is that correct? So now we have two separate equations that we can graph. So I'm going to go over here and I'm going to make a lovely little graph. Okay, so we have this here and we got this here. Okay, so for my first graph, 3x minus 2, I'm going to begin on negative 2. And then what is my slope, y'all? 3. So I'm going to go up 3 over 1. Up 3 over 1. Down 3, left 1. So this is one of my equations that I have graphed. Do y'all feel good about just a little refresher on graphing these? And then here we had 3x plus 3. So I'm going to start on positive 3. And then I guess I could go up 3 over 1. I'm also going to go down 3, left 1. Down 3, left 1. What do we notice about these two lines? They're parallel. So guys, these lines are parallel. They have the exact same slope. And they are parallel lines. So y'all, will these lines ever intersect? It does not matter how big you make it or how far you extend your graph. In this particular graph, there will be no solution. So guys, sometimes when you graph it, there will be no solution. Does that make sense? Are you guys tracking with me? Okay? Now, I will say, so if we graphed this on our graph, we would have seen, if we graphed it on the calculator, we would have seen 3x minus 2, and we had what, 3x plus 3, and we graphed those two lines. They are perfectly parallel, and there will be no solution to that graph. Do y'all feel comfortable with that as one of our answers? All right? Now guys, sometimes you will have a graph. You don't have to write this down, but you can just have your eyes up here. Sometimes you will have a graph that looks like this, where you have x plus 5, and you have 2x minus 7. Okay, so let's take a look at this graph. Do these graphs ever intersect on this plane? But will they intersect eventually? Yes. So guys, there is a solution to this problem. We just don't see it. Does that make sense, you guys? So it's only no solution if they're exactly parallel. These lines are not exactly parallel. But if you tried to calculate the intersection, it wouldn't work because there's nothing on there for them to intersect. Does that make sense, you guys? So then if we go here and we zoom out, and I'm going to zoom out based on the center here. Let's see. Now do we see where they intersect? Yes. So we can do the second trace intersection, enter, enter, enter. And it gives you, this particular one has an intersection of 12, 17. Do y'all feel good about that? About being able to find that even when it's not, when you see it right away. Does that make sense, guys? I will tell you, one of them, and then guys, you go back to Zoom Standard, and it brings you back here. One of the favorite questions that they'll put on there is they'll say, which graph has no solution? And they'll give you different options. This will be one of your options. Don't pick that one. It does have a solution. We just can't see it because it's kind of up here, right? It kind of goes whoop that way and that way. It's just off the screen. Does that make sense, guys? That does have the solution. We just can't see it. Are you guys okay with that? So you can do that little zoom out, and you can actually see where the solution is. All right, we're going to do one more example of graphing by hand. Awesome. All right, so I'm going to go ahead and draw a little line so I have it. All right, so this one, we're just going to have to make it a little bit smaller, and that's okay. So we will have 3x plus 2y is equal to 6. And then my second graph, or my second equation, is negative 6 minus 4y is equal to negative 12. All right, guys? So in order to, can we graph these right away? No, we cannot. It's super annoying. We cannot graph it. So what I'm going to do is I'm going to go ahead and solve for y. Now, guys, I'm going to go ahead and just bring my I'm going to subtract 3x. So it's going to be 2y is equal to negative 3x plus 6. Are you guys okay with me doing that? Subtracting 3x like that? And then we're going to divide by 2, which gives us y is equal to negative 3/2 x plus 3. So that's one of my equations. All right? My second equation, we've got to add 6x to both sides, so that gives us negative 4y is equal to 6x minus 12. We divide both sides by negative 4, and our final equation, our second equation, is going to be y is equal to negative 3/2 x plus 3. Because 6 divided by negative 4 will reduce to negative 3/2. Negative 12 divided by negative 4 is equal to 3. What do you guys notice about these equations right away? They're the same. So guys, these are the exact same line. This is another special case. So if we were to graph these, we would literally graph them just right on top of each other, wouldn't we? So if we were going to graph them, we would start at positive 3, and then our slope is negative 3/2, so we go down 3 over 2, down 3 over 2. Sure, that works. I'm going to draw my little line, so that's one of them. If I was going to graph the second one, y'all, same thing. Start at our 3, down 3 over 2, down 3 over 2. So literally, when are these two lines touching each other? All the time, everywhere. They're one of those, okay? That is like they're constantly touching each other. All right, guys? Constantly. So what are my solutions in this case? There are infinitely many solutions. There are infinitely many solutions because they intersect at every single point. What is another way that you think we could write that? There we go. We could also write it as all real numbers. Do y'all feel good about that? You can write it as infinitely many or all real numbers. All right, guys? Any questions for me on these? So guys, when you are graphing a systems of equations, you can have one solution, which I'm going to be honest, that's most of the time. All right, most of the time you have one solution. You can have no solution. That's when they're parallel. Or you can have infinitely many, and that is when they're literally the exact same line right on top of each other. Do y'all feel good about that? Excellent. So now, guys, we're going to see what this looks like from a practical standpoint. Okay, guys? So for this next part, you guys, I'm going to give you a couple little word problems. Does anybody else need this to stay here? So sometimes we have to get it into slope-intercept form, and then we graph it. And guys, you can graph these on your calculator. It's kind of nice. Okay, you can also graph it by hand. All right? Now, what I want us to do is we are going to take a look at why this even matters. All right? So, I'm going to talk about this with you. I'm actually not going to graph it here. I'm going to graph it on the calculator. All right? So you guys can write this part down here, but I want you to read through this right here. At a local fitness center, members pay a $5 membership fee and $2 for each class. Okay, each aerobics class. Non-members pay $3. Those non-members, they got to pay more for each class. So guys, the whole point of a system like this is for us to say, okay, so at what point would it be smart for me to buy a membership, right? Because there's going to be a threshold where it's like, oh, it makes more sense for me to buy a membership. How many classes do I need to attend for that to start making sense? This is a very cheap membership, okay? I wish this is how gyms worked right now, but they do not. All right? So, if we were going to do this, let's write two equations that represent this. So guys, first we need to identify our variables. So guys, the independent variable, in this case, my x, whoops. Well, let's write our equations first, and then we'll look at the variables here. So guys, for my members, they start off and they pay $5 no matter what, don't they? But then, how much do they pay for each class? $2. So guys, they pay $5 just for the membership, but then they only pay $2 per class. What about my non-members? Do they pay anything to just get in the door? But what do they have to pay per class? 3x. Does that make sense? They pay $3 per class. So guys, the x value in this case is the number of aerobics classes. Aerobics classes? That's weird. All right, we're going to go with that. The number of aerobics classes. Your y is going to be the total cost. Do y'all feel good about that? So how are we going to find the solution to this? Let's do it. All right, can you guys graph those two on your calculator, please? Graph those lovely two equations. We have 5 plus 2x. That's our member. And then we have also y equals 3x. Okay? Will they ever hit each other? Oh, it looks like they will, but is it going to be on this screen? So what do we need to do? Zoom out. Ooh, there it is. So everyone get there, and then once you've zoomed out, I want you to calculate the actual intersection point. You do the second trace, intersect, enter, enter, enter. Second trace, intersect, enter, 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 and we see that our intersection is 5:15. So that is our solution. But what does that mean exactly, y'all? What does that mean, 5:15? Yeah. In 5 classes, it costs $15 for both of them. Does that make sense? For both members and non-members. So y'all, what this means is that if you are going 5 times or less, you don't have to join. But if you're going to go more than 5 times, it starts to be cost beneficial to be a member. Remember guys, my membership line is this blue line. So see, look, it starts off above the red line. It costs more originally to be a member. But as you go, it starts to cost less. Does that make sense, guys? Are you guys tracking me? Okay, so in 5 classes, it costs $15 for both members and non-members. All right, guys? So after 5 classes, if you're going to go more than 5 times, you probably want to be a member. If you're going to go less than 5 times, it doesn't really matter. Does that make sense, guys? Because that's the threshold. All right, so let's do another guy right here. A large pizza at Palanzio's Pizzeria costs $6.80 plus 90 cents for each topping. The cost of a large cheese pizza at Guido's Pizza is $7.30 plus 65 for each topping. So we want to first write a system of equations. So guys, what would be our Palanzio equation? What does it cost just to get the pizza? $6.80. And then, if I want to add any toppings, how much is it per topping? So that's going to be $6.80 plus 0.90 times x. Do you guys feel good about that? So you guys can write this lovely little equation down. And then guys, what would be our second equation? Let's read it and think about it. Finn, what would you get for your second equation?
Y equals 0.65x.
Ooh, good job. 0.65x plus 730. Guys, on one equation, I did the y-intercept first and then the slope. On this equation, I did this. Finn did the slope first, and then he did the y-intercept. Does it actually make a difference when you graph it? Nope. So guys, those would be our 2 equations. So this pizza costs less originally, but each topping costs more. This pizza costs more originally, but each topping is less. Does that make sense, y'all? So let's find our solution. So x is the number of toppings, and y is the cost of the pizza. So how many toppings need to be added to a large pizza from both places in order for them to cost the same? Not including tax. However, if they cost the same and then they both have tax, they'll still be the same, right? They should be. Someone's taxing you different, don't go there. So guys, what would it be? How would you all figure this out? Did anybody graph it in their calculator? Let's do it. I'm going to zoom back to my standard here. I'm going to graph these 2 equations. 680 plus 0.90x plus 0.65x plus 730. So I have 2. Ooh, do they intersect each other? They sure do. Second trace, intersect, enter, enter, enter. So where do they intersect, guys? What is the intersection? 2, 8.6, right? It's 2, 8.6, if we can look at that guy there. Yep, 2, 8.6. So that, guys, means that you need to get 2 toppings for the pizza to cost $8.60. So guys, let me ask you this question. Eric, if I like a lot of toppings, which would be the better place to eat at? Like if I want to get a bunch of different toppings. Guido's, right? Because guys, remember, Guido's is this red line. It was the second one. So guys, the more toppings you get, then that's the smaller it's going to be. Also, each topping costs less money, right? But if you are my children who only eat cheese pizza, then where do you want to go? Palazzo's, because that's the cheaper pizza. Does that make sense, guys? Are you guys kind of tracking? So that's why these kinds of things are nice to see. All right? So now what I'm going to do is I'm going to pass out a little worksheet that we are going to work on together. So for this problem right here, I want you guys to write a systems of equations that, I don't know why she wants a clown to deliver them, but she does, apparently. And so, good old Miss Travis. So guys, I want you guys to write the 2 equations and then tell me how many balloons need to be ordered, all right, guys? So I want you guys to write those 2 equations and then find the solution. What is the threshold, right, of when are they the same? When does it cost the same for each company? Clowns are fun and singing balloons. Equation for clowns are, what is the equation for clowns are fun? If you think clowns are fun. All right, yeah, Eric, go for it.
1.25x plus 6.5.
Okay, so y is equal to 1.25x, because that's the price per balloon, plus your $6.20 delivery fee. Yep. Do y'all feel good about that? Okay, and then what is the cost, or what is the equation for our singing balloons here? What is it? Yeah, 1.95x plus $2. It's only $2 to deliver that guy, which is kind of nice. And then once we graph that, what is our solution going to be, y'all? What is it going to be? 16, and it's what, 1350? What is it? 0.7. 1370? So guys, how many balloons do you need to order for them to cost the same? 6 balloons. Because that is where they cost the same. Do y'all feel comfortable with that as our answer here? Do we feel good about that? Excellent. Okay, so what I want us to do, so yeah, it was $13.70, and guys, it costs $13.70 if you want 6 balloons. Okay, so if you want more than 6 balloons, you probably want to go with you want to go with clowns are fun, because that's less per balloon. If you want less than 6 balloons, you probably want to go with singing balloons. So it just depends on which one you want. Okay? Now guys, for these next problems, we are going to do these very similar. These problems we are actually not going to solve. I just want you to set them up. These are going to be very similar to the ones that we do on our homework, all right? So, on your homework, you're just going to have to set up the equation. You don't actually have to solve it, okay? And they're usually big, long paragraphs, so I want us to make sure we feel good about this. So Joey, our boy Joey, has a handful of dimes and quarters. So we're dealing with dimes and quarters. We know that there's 22 coins in all, so that's a total amount of coins. But the value of the coins, maybe threw it in one of those little things, is 355. So that's the total value, that's the total number. How many, how much? Write a system of equations that can be used to determine the number of dimes he has and the number of quarters he has. So guys, what is our unknown in this situation? The number of dimes and quarters. So it says define the variables that you use to write this system. So guys, you could define them as x and y, but personally, I would like to define the variables with something that's a little bit easier to identify. So I would say that D is my number of dimes. Are you guys okay with that? And Q is my number of quarters. Are y'all good with that? And now we're going to write two equations. And we're going to need to write a how much equation, and we're going to need a how many equation for the 22, and a how much equation. All right? So, let me ask you this. If I add my dimes plus my quarters, my number of dimes plus my number of quarters, how many total will I have? 22. That is the how many equation. We're dealing with how many dimes or quarters we have. Okay? And because it gave us a total. So guys, that means together, all of them together, we had 22 coins. Okay, so that was the how many. Now a how much equation. Well guys, this one requires a little bit of prior knowledge. How much is a dime worth? 10 cents. So if we multiply 10 cents by our number of dimes, that would be how much money we get from our dime. If we multiply 25 cents by the number of quarters, that's how much we get from our quarters. And if we add those two together, how much total do I have? $3.55. So that's my how many. This is my how much. Does that make sense, guys? There's like usually a how many and a how much equation. Okay? So using this, I want you guys to write the equation for number 3 here. There's going to be a how many and a how much. Number 4, you got 2 how muches. You don't have a how many. But guys, here we need to see how many and how much. Now, the person in number 3 makes me very sad because they're counting the calories on the mints and the gum that they take. So please don't be in a position where you feel like you need to count the calories on the mints and the gum that you have, okay? Oh. Please.
I do that.
Eat the mint, okay? So, I understand. I just can't handle that, personally. Oh. All right.
Okay.
So here we go. So how do you get calories from gum? I guess it's from the juice. Is that right? The sugar. I guess because you don't swallow it. I guess it's what it. I don't know. I don't know. I don't know what the calories are in sugar-free gum. All right. So I just am sad. Okay. All right. So I'm sad for them. Like, oh. All right. So the number of calories in a mint is 3 times the number of calories in a stick of gum. So we got mints and we got gum. There are 70 calories in 5 sticks of gum and 3 mints. Alright? So we want to write a system of equations that determines how many calories are in a stick of gum and how many calories are in a mint. So what we don't know is we don't know the number of calories in gum, and we don't know the number of calories in a mint. Now guys, do I need to label them G and M? No. Could I label them X and Y? Sure. You just have to keep track of which one means X and which one means Y. That's why it's so important to write it out to the side, okay? So that you can get it, so you can do it, keep it there, okay? Oh, I guess my mint is pink, sorry. And my gum is green. All right, so guys, the number of calories in a mint is 3 times the number of calories in a stick of gum. So that means that my mint, this is my how many, my mint is equal to what? If it's 3 times, what are we going to do to the G? 3 times G. Do y'all feel good about that? Your mint has 3 times the calories of your gum. And that makes sense. Also, just like thinking about it, right? Hopefully mints have more calories than gum because they're more satisfying. Okay? All right. Then there are 70 calories. So that's a how many equation. Now we're going to do a how much. 70 calories in 5 sticks of gum and 3 mints. So I'm going to go 5G plus 3M is equal to what? 70. So technically, guys, could we solve for this? Yeah, we would just have to define it as like y and x, subtract, divide, all that stuff, right? I'm not asking you to solve, I'm just asking you to set it up. Do y'all feel comfortable with that? Okay. So we're going to do these last 2 and then we're going to be done. A group of friends go out for lunch. If 2 order hot dogs and 4 order hamburgers, the bill will be $23.50. Oh, but it has a second circumstance. If 5 have hot dogs and only 1 has a hamburger, the bill is $18.25. So write a system that can be used to determine the cost of the hot dog and the cost of the hamburger. So what is our unknown, y'all? We don't know how much they cost. So what do we want to name our variables? Can someone give me a name for the variables? H for hot dog? So that's the cost of a hot dog. I guess you can't do H and H. So we'll do H and B. Are you guys okay with that? That's the cost of a hamburger. So y'all, how would we write our equation here? How do we write our equation? We have 2, we don't know the how many, we have 2 how muches. So guys, if we had 2 hot dogs and 4 hamburgers, how much did that cost us? $23.50. Good. So that's one of my equations. What would my second equation be? What would my second equation be, y'all? 5H, because 5 hot dogs plus 1B, or can I just write B, is equal to $18.25. Right? Is that correct?
Yeah. 16 equals that much.
I know. So it probably means that the burgers, I don't know, are worth more? Or they cost more? So it's going to be interesting if we actually solved it. I'm not asking you to solve it. I'm just asking you to write it.
Get your burger.
Okay? Then we go here. The larger of 2 numbers is 9 more than twice the smaller. The sum of 2 numbers, so that's one of our equations, probably. The sum, what does sum mean, y'all? Addition of the numbers is 3 less than 5 times the smaller. Write a system that can be used to determine what the 2 numbers are. So guys, I'm going to say L is my larger number. I'm going to say S is my smaller number. Do you guys feel okay with that? So what would be my two equations? What would we have here, guys? Well, the larger number is, so that's my equals, 9 more. What does that mean, guys? Are we going to be adding, subtracting? We're going to be adding 9 more than twice the smaller. So I'm going to say 2S plus 9. Are you guys cool with that? Could I also have done 9 plus 2S? Sure. Same thing. Now, the second equation says the sum of the numbers. Well, what's the sum? How would that look? L plus S, right? Or S plus L. Same thing. L plus S or S plus L is equal to 3 less than 5 times the smaller. So 3 less, what does that mean we're going to be doing? Subtracting 3. So we're going to be subtracting 3 at the end here. What are we subtracting 3 from? 5 times the smaller. So that would be 5S. Do you guys feel good about that? So this would be how you would set up those systems of equations. So guys, on your homework, you are going to have some problems where you will have to set up a system of equations. So guys, let me show you what it looks like. Alright, so on your homework today, you are going to have to set up a system of equations. It's going to give you the problem. You get to define your letters, and then you get to write the equations. You don't have to solve it. Are you guys okay with that? Okay, you don't have to solve it. All right. Now, what I want you guys to do real quick is I'm going to take a look at these. Flip your paper over. All right, flip your paper over. On this back side, guys, this is not, I'm not taking this up for homework, but this is really, really good practice. All right, guys, what I want you guys to see here is I want you to circle 2, 3, 4, 6, and 9. Because, guys, if I was going to graph a system of equations, I would probably want at least one of my equations to be in slope-intercept form. Does that make sense? For number 2, neither of those are in slope-intercept form. You would have to change both of them. That kind of sucks. This one of them's already there. So you only have to change one of them. Does that make sense, guys? For number 3, they're both there. Okay, number 4, neither of them are there, but that's a special case. So that's why I have you circle it. For number 6, one of them's already there. You only have to change one of the equations. Does that make sense, guys? So as you're doing these, you would only have to change one of your equations. Then you could graph them both, find the intersection, and do it there. Now, y'all, if you do not have a graphing calculator at home, you can still totally graph these, okay? So, for example, you can do it here with your Desmos. So, if I was going to graph number 3, guys, this is one of the reasons I love Desmos. So, I can type this in, and it would be y equals x plus 5 and y equals 2x minus 7. So I have my 2 graphs right here. And guys, Desmos is great because you can just zoom out really easily with your mouse. And then guys, when you click on it, it gives you the solution, 12, 17. So you can do it with your calculator or you can do it on Desmos. So guys, I just gave you all the answer for number 3 there. What is that going to be? C? Because that's 12, 17. So the answer right there is going to be C, because your solution is 1217. Do y'all feel good about that? Yes? No? Maybe so? Cool. Awesome. So what I want you guys to do is I want you guys to take a look at that. And then, so guys, try to do the ones that I've circled. And you have to convert it to slope-intercept form and then graph it. And your answer, it will be one of these answer choices up here. And they will only be used once.